All right, our new topic will be on polygons, and we're going to look at what are called convex polygons. Yes, Penelope? Not right now. Let's look at the most common one, the triangle. We've got three sides here, and I'm going to go ahead and develop a formula for us. We have three sides, and the number of 180s, obviously we'll have will be 180 like this. You say, what is that? Well, I'm just checking to see the sum of the angles here, what we're going to get when we look at just the normal three-sided polygons. But of course, we can have four sides. So if we go to this one here, which is a four-sided, and I go ahead and see if I can, let me do it this way. I want to get it a little bit accurate. Let's say I draw a diagonal. 1 minute, Luke. It's terrible. Don't like that. Let me try again. Four sides. That better?
Yeah.
All right. Yeah. Go ahead and draw a triangle. And triangle has three sides. Going to be have 180, and that's just a measure of the number of 180s in terms of degrees for the angles here. We all know that every triangle has got 180 degrees when you add up the interior angles, and that's what we're after. Yes, Luke?
I was going to ask, it says number of 180s, and all it says is 180.
Yeah, I should say, yeah, let me tell you what we're talking about. We're talking about the sum of the interior angles. That's what we're after here. Sum of the interior angles. Let me just give it a subtitle there. All right. So for a triangle, we have 180. But how about for this one? Well, we have actually two triangles here. One here, and we have another here. So we'd have 180 there, and for this one we'd have another 180 here. So we'd have, for a four-sided polygon, we're going to have two 180s.
So the
And
whole
it's
thing would equal 360.
It's always going to be 360 for any quadrilateral. So you might as well know that. 360 for the sum of all the angles in here. This one plus this one plus this one plus this one is going to be always two 180s. And then finally, let's take a pentagon, a five-sided here. How many 180s do you think we'll have there? Let's go ahead and take a look at the number of 180s we'll have. Let me come in here and do this. That would give me 180 there. I think I could do another one right here. So we'd have one 180 here, we have another in here, and a third one here. So for a five-sided, we have how many 180s? We got three of them. I'm going to stop right here and see if we can just see the pattern as it goes. Listen carefully, please. When we've got three sides or three angles, we got one 180, that's two less. When we got four sides, we have two 180s, still two less than the four. And finally, when we have five sides, we have three 180s. How about if we have any number of sides? Let's say X sides. Who can tell me how many 180s we have? Josh?
I just had a question. If you're trying to find the 180s and you're drawing the lines, are the lines allowed to overlap each other?
No. Okay, because essentially what I'm trying to do is, I'm just trying to find, if I add this angle, plus this angle, plus this angle, plus this angle, all interior angles now, how many degrees I'm going to get. So we don't want an overlap, we just want to have individual triangles. And that's what we're getting here. So again, for 3 sides we have 2 less 180s. For 4 sides we have still 2 less 180s. For 5 sides we have 3, 2 less 180s. For x sides, how many 180s do you think we have? It's always 2 less. It's going to be x minus 2 180s. It's always 2 less. Just a minute, Amber. All right, so in general, for n sides, I'm just going to use n because books use n for n sides, and n just means any number of sides. And if it has n sides, like this triangle, it's going to have n angles as well. We would have, here's the formula coming now, n minus 2 times 180 degrees. And this would be the formula for the sum of the measures of the interior angles of any, what is called a convex polygon. Yes, Jessica? Huh? What is what?
What did you write on your
For n sides. We have n sides, which means any number of sides. Here's an example. Let me just go back to one that we just looked at. Let's say we have a quadrilateral, and this could be a square, it could be a rectangle, and we'll study these. It could be a square, a rectangle, it could be a rhombus. Here's a question. What or find is the sum of the interior angles of a, let's say a rhombus. RHOMBUS. Well, what is it going to be? How many sides does a rhombus have? It's got 4. Kind of looks like this, and we'll study them somewhat. Kind of looks like this. It's like a parallelogram. It's going to be 4 sides. So what we use that formula like this: 4 sides or angles minus 2 times 180. Grant, you know how many?
360.
Yeah, it's going to be 2 times 180, as we said up here. That's going to be 360 degrees. So you see, it's much different enough than the regular triangle. We're going to be able to do it for octagons. How many sides for an octagon? Do you remember? 8. For a decagon, you remember? 10. And dodecagon, any of you remember that from maybe chapter 3? How many sides? Dodecagon? That's 12. All right, so that's the idea right here. Let me go and see if I could.
Is it possible to have something with 11 sides, Mr. Henry?
Yes, good.
What's that called?
That's an 11 gon.
Wow, original.
13 would be a 13 gon, and so on. All right. Now, yeah, indeed. If it's over 10, they usually call it just whatever the number of sides is on GON at the end.
Except for 12.
Yeah, 12 is different. All right.
Well, it's special, but no, but
Let me give you a special word concerning regular polygons. regular. I probably gave this to you before, but I don't remember. Any of you remember getting this? A regular polygon, what it is? Regular polygon, I'd like you to notice because your worksheet is going to have this on it. Regular polygon is a polygon which is equilateral and equiangular. This is a polygon polygon which is equilateral. Jessica B, what does that mean again, equilateral?
All sides.
Yes, and equiangular. Equiangular. What does that mean again, Bridget? Equiangular.
All the sides are equal. No, all the angles are.
All the angles. And yet, who can give me an example of a regular polygon? One that we see all the time, right?
Square.
A square would be one. Look up for a minute. You think those ceiling tiles would be like regular polygons?
Yes.
They would be, all of them. How about a stop sign?
That's an off. Yeah.
Is that regular?
Yes.
Yeah, that would definitely be. So whenever, if you see a diagram that looks something like this, I'm just gonna maybe draw, oops.
A cone.
Try again.
Mr. Henry, what would a cone be considered? It's got like
A cone?
it's got like a trombone head and a circle bottom.
That would be a different circular shape, maybe. But kind of different than what we're looking at. Regular would be like this. The sides are the same, and the angles are the same. So just look for that when you're talking about regular. All right. Now let me give you another formula. Let me go to another sheet before I get to this example. This would be, I'm going to look at the sum of the exterior angles. Let's say sum of exterior angles by the time I develop this for you, but I'm just going to go ahead and give it to you right now. The sum of the exterior angles of any regular polygon is 360 degrees. You say, is that always true? Yes. Kind of like twirling around in a circle. If you go all the way around, it's going to be 360 degrees. So the sum of the exterior angles of any polygon, doesn't have to be regular. I'm going to emphasize this, always equals 360 degrees. Okay? So we're going to take an example pretty soon. In fact, let me go ahead and give you a worksheet to work on this example. This 16 is on the worksheet and 19 is also on the worksheet. So let me take a minute and give you the worksheet so you can take a look at it.
Is this still recording? Yep. Mr. Henry, this thing is still recording.
I know. You sing a song for us and
No.
Right now.
I'm not about that.
Alright. Yeah, I want to pick this up as we go through number 16 together. Alright. Let me take a look at it. Alright, let's take a look at one of these together. I got number 16 here. And the question is find the value of x. So this angle here is 105. How about this one? 142. This one? 140. All right, let's keep going. This one? 144.
No, 24.
124.
Yes.
124. What's the other one?
X.
That's the X. And then this last one?
Well, the corner is 88.
88. All right.
Shouldn't that be 90?
It looks like it'll be 9. It's pretty close. All right, so we're going to find the value of X? Well, we're going to have to revert to this formula. Where should I put this? Let me take it here.
X equals a lot of numbers.
N minus 2 times 180 will give us the sum of all the interior angles of this polygon here. How many angles do we have? Or how many sides? The same. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's going to be 6 sides, which is 6 minus 2 times 180. Luke, you should be taking some notes here.
I'm watching.
I don't want you to watch only, I want you to write as well. So it's going to be 4 times 180. This will give me the sum of all the angles in here. It should be 4 times 8 is 32. 4 ones 4. It's going to be 720 degrees total in here. And now, how am I going to find the X?
Add the all of this subtract from 720.
Yes, so we're going to have to add these all up, and I'm going to ask someone to help me to calculate. Now, 105 plus 142 plus 140 plus 124 plus, what's the other one, 88 plus X. It's going to be 720. This total right here, can I have someone give me that, what that would be?
599.
Confirmation, please. 599, okay. 599 plus that missing, that one lost missing sheep X, we're going to get it. Subtract 599 from both sides. And that should give us our answer. X is equal to almost 1 what? 121. Yeah, 600 would give us 120, so this is just 121. So that's what X would be, right? That's the way you'd find that. How about this one with the exterior angles? Let's take a look at this one as we close off our time here. This is number 19. I'm going to put the numbers in here. You can work on your work. What's 90?
93.
I'm looking at the wrong thing. 93, all right? That's one exterior angle. What's the other one?
75? Oh, that's X.
That's a 2x here.
No, that's just X.
Is it X?
Yeah, no, let's look at number 20.
Looking at the wrong thing. X. All right, and the other exterior angle?
That's 2X. Wait, no, that's
2x, okay. And finally,
That's 75.
75.
70.
All right, 70. What I told you was the sum of all the exterior angles always add up to 360. So here we go, we're going to set this up. Luke,
Yeah.
should be writing now. I'm going to have 93 plus, I'm going to go this way, plus x plus 2x plus 70 equals 360. Always 360 because it's essentially going all the way around in a circle.
It's 75. It's 75, not 70.
75 here?
Yeah.
All right, thank you. So here we go. Change this. We have 3 x's over here. 93 plus 75, that would be 168. That's going to be equal to 360. I'm going to subtract the 168 from both sides. You guys should be finishing this up. Including you, Grant. 168. Let me come over here with it. We have 3x is equal to, that would be 2, 6 from 15 is 9, 192, and divide by 3, x is equal to 3, 6 is 18, and 64. Anybody got 64? 64. All right. So the key here is to remember that the sum of the exterior angles is always 360. Write this down for your homework, Luke.
Yeah.
Do 1 through 21. Just do the odds there. 1 through 21, and then we'll continue on the worksheet. Well, 1 through 21 odds here. All right, wait for the bell.